Hello everyone. In today's lesson we are looking at Chapter 4, Section 6, Isosceles Equilateral and Right Triangles. Our objectives are to use the properties of isosceles, equilateral, and right triangles. Vocabulary. Base angles. Base angles are the two angles adjacent to the base of a triangle. If you remember from our notes from Chapter 4, Section 1, when we have an isosceles triangle, the side that is not equal to the other two sides is called the base side. And so your base angles are the angles that are on the base side. Another way you can look at it is that your base angles are opposite from your congruent sides or opposite from the legs of an isosceles triangle. Vertex angle. The vertex angle is the angle opposite the base of a triangle. So your vertex angle is opposite the base side. Theorem 4.6, base angle theorem. If two sides of a triangle are congruent, then the angles opposite them are congruent. So if we have line segment AB congruent to line segment AC, then angle B, which is this angle over here, is congruent to angle C, which is this angle over here, which, as we said in the vocabulary, your two base angles are opposite the congruent sides of your isosceles triangle or the legs of your isosceles triangle. Theorem 4.7, converse of the base angles theorem. If two angles of a triangle are congruent, then the sides opposite them are congruent. If angle B is congruent to angle C, then line segment AB, which is this line over here, is congruent to line segment AC, which is this line over here. Again, the congruent angles are opposite the congruent sides of an isosceles triangle. Corollary to Theorem 4.6. If a triangle is equilateral, then it's equiangular. Corollary to Theorem 4.7. If a triangle is equiangular, then it's equilateral. Meaning if you have an equilateral triangle where all of the sides of the triangles are congruent, then you have an equiangular triangle where all of the angle measures are congruent. Conversely, if you have an equiangular triangle where you have all of the angle measures the same, then you have an equilateral triangle because all of your side measures are the same. Example 1, using isosceles triangle, find the value of y. Notice that y represents the measure of a base angle of an isosceles triangle. The reason why I know it's an isosceles triangle is because I have these two tick marks, which means the angles opposite the sides that have the tick marks are congruent. The angle that's opposite this side is this angle over here, and the angle that's opposite this side is this angle over here, which means these two measures are the same. From the base angles theorem, the other base angle has the same measure. I need to find the value of y. In order to find the value of y, I need to know what this vertex angle is. Well, looking over here, I know that this is a straight line and that these two angles add up to 180 degrees. So I can find this angle measure by knowing that 70 plus this angle is equal to 180. Solve for this unknown angle by subtracting 70 on both sides, and I get that this angle measure is 110 degrees. The vertex angle forms a linear pair with a 70-degree angle, so its measure is 110 degrees. We know 110 degrees plus y, and the reason why I have two y's is because I know this measure and this measure is the same, so I can say that this is y as well, is equal to 180 degrees. Simplify y plus y to get 110 plus 2y is equal to 180 degrees. Solve for 2y by subtracting 110 on both sides, and you get that 2y is equal to 70. Isolate y by dividing by 2 on both sides, and you get that y is equal to 35. Alright, checkpoint problems number 1 and 2 are yours. For each of these problems, solve for x and y. Theorem 4.8, hypotenuse leg HL congruence theorem. So far we've learned about 4 different types of theorems or postulates that we can use to prove that triangles are congruent. We're adding one more to it, and that is the hypotenuse leg. if the hypotenuse and a leg of a right triangle are congruent to a hypotenuse and a leg of a second right triangle, then the two triangles are congruent. Meaning, if line segment BC is congruent to line segment EF, which is the leg of a right triangle, and line segment AC, which is the hypotenuse of a right triangle, is congruent to line segment DF, which is the other hypotenuse, and you have a right triangle, then you can say that triangle ABC is congruent to triangle DEF using the hypotenuse leg congruence theorem. Example 2, proving right triangles are congruent. The pole holding up one end of a volleyball net is perpendicular to the plane containing the points W, X, Y, and Z. Each of the lines running from the top of the pole to X, Y, and Z uses the same length of rope. Prove that triangle VWX, triangle VWY, and triangle VWZ are congruent. We are given that line segment VW is perpendicular to line segment WX, and line segment VW is perpendicular to line segment WY, and line segment VW is perpendicular to line segment WZ. We're also given that line segment VX is congruent to line segment VY and line segment VZ. Prove that triangle VWX is congruent to triangle VWY, congruent to triangle VWZ. The notes does this proof in the form of a paragraph. We are just going to do it in the form of a 2-column proof. To start, I'm going to redraw my 3 triangles. So I'm going to separate these 3 triangles so I have better information about it. So here are my 3 triangles that are broken apart so I can see each triangle separately. I'm given that line segment VW is perpendicular to line segment WX, and line segment VW is perpendicular to line segment WY, and line segment VW is perpendicular to line segment WZ. That's a given. Because they are perpendicular, I know that angle VWX, which is this angle over here, and angle VWY, which is this angle over here, and VWZ, which is this angle over here, are right triangles, and that's the definition of perpendicular lines. From here, I know that angle VWX is equal to angle VWY, which is equal to angle VWZ, and they're all equal to 90 degrees because that's the definition of right angles. I am given that line segment VX, which is this line here, is congruent to line segment VY, which is that line there, and that's also congruent to line segment VZ. Notice how in each of these triangles they have the same line segment, which is VW in all of them. So all 3 triangles share the same line segment, which is VW. So I can say that line segment VW is congruent to line segment VW using the reflexive property of congruence, and I'm going to mark this on my triangles. So I now have 3 pieces of information. I have a leg, a right angle, and a hypotenuse congruent to a leg, a right angle, and a hypotenuse congruent to a leg, a right angle, and a hypotenuse. So I can say triangle VWX is congruent to triangle VWY, which is congruent to triangle VWZ, using the hypotenuse leg theorem. All right, checkpoint problem number 2 is yours. You are given that line segment RV is congruent to line segment ST. You're also given that angle RTV and angle SVT are right angles. You need to prove that triangle RTV is congruent to triangle SVT. All right, that's it from me. I'll see you all soon.